In this video, we're going to look at our trigonometry graphs. So these are our sine, cos, and tan graphs. So we're going to look at the sine graph first of all. But before that, can we just mention that we need to be familiar with our SOHCAHTOA, so from our GCSE, normal GCSE maths, and also the sine rule and the cosine rule, which you would have seen in your M4 and M8. So you need to be able to use these as well. They could come up in the GCSE further maths question. Okay, for your sine graph, first of all, you want, we're going to do it from minus 360 to plus 360. In an exam, they could give you, they normally give it within any range of 360 degrees. So quite often it's from 0 to 360, or quite often it's going to be minus 180 to positive 180. But we've gone all the way from minus 360 to positive 360 here. Now, when you're doing this, you want to test every 90-degree interval. So on your calculator, just put in sine of minus 360 equals, find out what it's equals, sine of minus 270 equals, sine of minus 180, sine of minus 90, sine of 0, sine of 90, sine of 180, sine of 270, sine of 360. And it's a curved graph, remember. So you should be given, when you should get points, it's 0, then it's 1, then it's 0, then it's minus 1, then it's 0, then it's 1, then it's 0, then it's minus 1, and then it's 0. And it's, as I say, it was a curved graph, so you would just do your over it, you would do very bad there, you can see, but you just do your curve over it, so you can see the general shape that I've done. Okay, and that's as easy as that. So that's your sine graph. So your sine graph goes up and down, and it starts at 0. Sine of 0 is 0. It is worth your while to learning those. Sine of 0 is 0. Sine of 90 is 1. Sine of minus 90 is minus 1. It's worth your while remembering those. And as well, sine of the first four even would be worth your while remembering: 0, 90, 180, 270, and 360. So learn off what they are. It will make life a lot easier for you. Okay, the next one is a cos graph. Again, we've gone from minus 360, minus 270, minus 180, minus 90, 0, 90, 180, 270, 360. And again, just like the sine, the cos graph goes from 1. The maximum value it has is 1. Minimum value is minus 1. So it goes from 1, oscillates between 1 and minus 1. So again, you just put in cos of minus 360, cos of minus 70, minus 270, and so on, all the way along to get all your points. And then you just label them. So you just, join them up, I should say. So you've got these points would be the points you would get, and then you just join them up with a smooth curve, and you'll see you'll get the resulting graph up above. Okay. Okay, the next one is the tan graph. Now, it takes a wee bit more learning, I think, really, for you to be able to draw this thing well. So, if you hit on your calculator, we said in previous ones, test it out every 90 degrees. But if you hit tan of 0, that's absolutely fine, you'll get 0. But if you hit tan of 90, it comes up as a maths error. So, it's as if the reason for this is tan is undefined at 90. So, it doesn't actually exist. You can't have tan of 90. It doesn't exist. And every 180 degrees, the same thing happens. So at tan of 270, it doesn't exist. Likewise, if you go back the way, tan of minus 90 doesn't exist, and tan of minus 270. So these are called asymptotes. So the first thing you want to draw when you're drawing your tan graph is do out all your markings and your axes, obviously, and then you want to do your mark on your asymptotes. So the first, if you learn where the first one is, so it's at 90 degrees, and then every 180 degrees forwards or backwards, there's also going to be one. So if there's one at 90, that's your first one, there will be one at 270, and there'll also be one at minus 90, and then back another 180, there'll be one at minus 270. So mark these vertical dash lines on first. So these are asymptotes. So at an asymptote, your line gets infinitely close to your asymptote, but it never actually touches it. The next thing you've got to learn is the general shape. So we say that this graph is periodic, and its period is 180 degrees. So it means after every 180 degrees, it repeats itself. So if I just draw over this here, you must learn this general shape, and it's the same general shape every 180 degrees. So I've started down here after another 180 degrees, and it's going again. And this last wee bit, I don't have can't do a full one of these. It's just a half version of it. Oh, very bad, but you can see roughly where it goes. And likewise, if I go back from here to here, it's 180 degrees. So I can draw it that way. And the last wee bit is just a wee half version of those. And that's it. So you can see roughly how I can draw this thing out. So as it says here in bold here, it is vital that you indicate asymptotes on the tan graph, and that's it. Okay, it says here, sketch the following graphs for the required range of x. So the required range is important. That means our graph, we are going from 0 to 360. And the above ones I gave you was minus 360 to positive 360, just 0 to 360. So we're looking at the big squares here. So that's one big square, 2, 3, 4, 5, 6, 7, 8. So I've got 8 squares here. I'm going to do 2 of these squares for 90, 2 of these bigger squares for every 90 degrees. So here, first thing I'm going to do is mark on, that's going to be 90, that's going to be 180, that's going to be 270, and that's going to be 360. And again, I'm just going to hit sine of 0. Sine of 0 gives me 0. Oh, sorry, I'll mark on as well. I know my graph goes from 1 down to minus 1. So I've got my axes marked first before I do anything. Then I do sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is minus 1. Sine of 360 is 0. So I've got points, you can see them here, sorry. This one, 0, 0 at 90 and then 1 at 180 and 0 at 270 and minus 1 and 360 and 0. So I'm going to pause the video and I'm going to do my best to draw this as best I can. Okay, as I started to draw this thing, I drew this wee bit and then I thought, well, I've done that quite well. What I'm going to actually use is this wee section to draw it again. So if you just watch how I'm doing this, and you can sort of think about this the same way. It is the same shape. All the sine graph, the whole sine graph is made up of the same wee shape repeated. So if I've just copied that and I paste that again, and if I just imagine I have it here and I just spin that around, so I flip that around, you can see that would make the next wee bit. I just maybe haven't got just quite right. That makes the next wee bit of the graph. Likewise, if I copy that again and I paste it, and how will I get to the next bit is I will rotate it around this time. So it'll rotate around this way, and I can bring that round to here. And you can see, not quite, but you can see it sort of worked quite well. And I'll paste that again, swing it round over this way. Let's have a look and see if that matched up. Not quite, spread it out a wee bit, but you can see. Okay, so that was quite useful just to show you that it's the same, this wee quarter of this graph really, it's exactly the same shape, just repeated another 3 times, and just here, from here to here, I've just flipped it horizontally, and what I did is I rotated it 180 degrees, and then I flipped that horizontally again. So it's the same wee shape, makes it up, and this allows for something we'll see later on, because it's the same bit of the graph is repeated, so it is a symmetrical thing. Okay, in this one I've gone on to my Cos graph, and I'm going to do my Cos graph it asks me to do from minus 180 to plus 180. So I'm going to say this is my minus 180, bit of a strange scale they've got here, but it's fine. There's minus 180, minus 90, there's my origin, that's going to be 90, and that's going to be positive 180. And I'm just going to do my 1 up here on my vertical axis, then minus 1 down here. Doesn't really matter. I could have stretched it out a wee bit longer, higher I suppose, but it's absolutely fine. Okay, I'm going to do one section of this as best as I can. Not great. I will stretch that out a wee bit, I think, just make it a wee bit longer. That's maybe a wee bit better. Okay, so you can see I've got this wee section, and what I'm going to do is repeat that. Obviously you would do this with pen or whatever, but I'm going to just bring this one over here. I'm going to flip it over this way. You can see that's one wee section. I could copy that again, and then what I could do this time is rotate that by 180 degrees. If I rotate that by 180 degrees, that would be in here, and that's that wee bit. And I'll copy that one again, and I'll bring it over here and hopefully flip it around. I'll put it here and flip it around. So you can see I've done that. Now if you were doing that yourself, again I've just done it that way just to show you that the whole thing, it is just made up of the one wee section of graph, and that is just repeated ever so slightly. So this wee section here got rotated 180 degrees to get this section, and then that gets flipped horizontally to get this section, rotated 180 degrees to get this wee section. So it's the same section is repeated the 4 times, or the 3 times, I suppose. Okay, tan graph. Now this is a tricky one. We want to do this one between 0 and 180, so we might as well do put your 180 at the very end here, and then my 90 is here. And the most important thing to do, 2 things to note here, but first of all, there is no vertical scale on this. The reason there's no vertical scale is it goes up to infinity. So the tan graph actually shoots up to infinity, and when it shoots up to infinity is at at 90 degrees. So at 90 degrees, there's, if you remember the word we used, it's an asymptote. So you draw a dashed vertical line, I should say. This is your asymptote. And then what happens this graph is it goes very roughly like this. That is far too rough. We'll go out to try that again. It goes quite flat and then it scoots up vertically. So that's what happens here. Now, if I take this section and I rotated it round, so that would be the same wee section as if it were like this. So I imagine, I'll put that bit down here now. Why is it not moving? There we go, technical errors. Okay, and you can see that would be the same thing. So this wee section is exactly the same shape as this one, as bad as mine looks, but that's all you're going to have. The only other thing I might mark on here would be my origin just, and that's it. But that's my tan graph from 0 to 180. If you're continuing on along, you would rotate this bit by 180 degrees and it would scoot up, it would go up this direction and so on. And then you'd have another asymptote, remember, at 270 degrees and so on. But here, remember, you only draw what they ask you for. So in this case, it was 0 to 180, so we're absolutely fine. Okay, this one, they've asked you to do the sine and draw sine that's in range -90 to 270. So the first thing I'm going to do my horizontal axis. So I'm going to do -90 here. That's going to be 0. That's going to be 90. That's going to be 180. And that's going to be 270. So I've used the full width of the thing, which is good if you can do it. I haven't used the full height for the next bit. I just didn't like going on these bits at the very top. So I'm just going to go here. And that's going to be 1 and -1. So remember, sine, maximum value of sine is 1. Minimum value is -1. Okay, put in sine of 90 in your calculator. You're going to get a 0. Put in a sine of 0. You're going to get... Sorry, put in sine of 90, you're going to get -1. Put in sine of 0, you're going to get 0. Put in sine of 90, you're going to get 1. Put in sine of 180, you're going to get 0. Put in sine of 270, you're going to get -1. So just to show you this one a little bit differently, instead of doing it with the wee quarter bit and then just repeating it, I'll just draw this one. So I'll just pause the video and do this. Okay, not too bad. So you can see it probably could have pulled this one up a wee bit higher at the top here. So it does go up to 1, but you want to avoid a flat bottom at the top or at the bottom here. So it's not too bad a diagram here. Okay, folks, you're now ready to do fairly easy exercise on drawing trig graphs. It's exercise 4A, question 1 to 6.